In this problem, we're going to find the absolute extrema of the function x squared minus 4x. Now notice here we are working on the open interval negative infinity to infinity. Since there's not any interval specified, we're going to assume that we're working over the entire domain of the function. Our first step in trying to find absolute extrema is to first find critical values. To find critical values, we need to find the first derivative. So we're taking f prime of x, which is equal to a 2x minus 4. To find the critical values, we're going to set f prime of x equal to 0. So we're setting 2x minus 4 equal to 0. Solving for x, we get 2x equal to 4, so x is equal to 2 is our critical value. Since we are working over the open interval negative infinity to infinity, and we only have one critical value, this allows us to use the maximum minimum principle number 2. What the maximum minimum principle 2 tells us is that since we are not on a closed interval and we have exactly one critical value, then that one critical value is going to be our absolute extrema. To determine whether our critical value is an absolute max or an absolute min, we use the second derivative. So let's find the second derivative. So f double prime of x, taking the derivative of the first derivative, we get that the second derivative is 2. So since the second derivative is 2, regardless of what x is, so if we take f double prime of 2, we still get 2. So the second derivative is positive. Since the second derivative is positive, this tells us that we have an absolute minimum at our critical value. So next, to find what the absolute minimum value is, we're going to plug 2 into our original function. So f of 2 here is going to be 2 squared minus 4 times 2, which comes out to be a negative 4. So our absolute minimum then is a negative 4, occurring when x equals 2. So we found the absolute minimum of negative 4 by using the maximum minimum principle 2, since we only had one critical value and the interval was not closed. In this next example, we're finding the absolute extrema of the function x squared minus 10x over the closed interval 0 to 6. Our first step in finding absolute extrema is to take the derivative to find the critical values. F prime of x here is going to be a 2x minus 10. Now to find the critical values, we're going to set the derivative equal to 0. So we're setting a 2x minus 10 equal to 0 and solving for x. So we have 2x equal to 10, so x is equal to 5, which is our only critical value here. Since the function is a polynomial function, it is defined for all x values, so we don't have to worry about x values for which the function is not defined over the interval 0 to 6. Since we are working on a closed interval and there is only one critical value, we could use either the maximum principle 1 or the maximum principle 2. Since it's pretty easy to find the second derivative, we will use the maximum minimum principle 2. So let's find the second derivative. F double prime of x is equal to 2. Therefore, when we plug our critical value 5 into the second derivative, we get 2, which is greater than 0. So since our second derivative is positive, we have an absolute minimum at x equal 5. To find what the absolute minimum value is, we can plug 5 into our original function. So we take f of 5, which is equal to 5 squared minus 10 times 5. So we get a negative 25 as our absolute minimum value. Now since we are working on a closed interval, the extreme value theorem tells us that on a closed interval we must have an absolute maximum value and an absolute minimum value. We have found our absolute minimum value. Now in order to find our absolute maximum value, we look at our endpoints. Since we only had one critical value, and that was an absolute minimum, then that means our absolute maximum must occur at one of our endpoints. So we're going to check our endpoints, which are 0 and 6, and we're going to plug those values into our original function to determine which one is our absolute max. If we plug 0 into our original function, we have 0 squared minus 10 times 0, which gives us 0. If we plug 6 into our original function, we have 6 squared minus 10 times 6, which gives us a negative 24. Since 0 is greater than negative 24, then that means our absolute maximum value is 0, and that occurs at the x value 0. So in this example, since we only had one critical value and we were working on a closed interval, we went ahead and used the maximum minimum principle to determine whether our critical value was an absolute minimum or an absolute maximum by using the second derivative. However, when working on a closed interval, we could also use the maximum minimum principle 1, in which case we create a list of the endpoints and critical values, and we plug each of those values in the list into the original function to determine which one is the absolute maximum and which one is the absolute minimum. Either method would work in this case. We can check our work in our graphing calculator by hitting y equals and then typing our function into y1. So typing in x squared minus 10x. Next, when we go to graph this, let's make sure we have our viewing window set appropriately. We're looking at the closed interval 0 to 6. So I've set the y min to be 0 and y max to be 6. Our x min to be 0 and our x max to be 6. Now for our y's, we found that we had an absolute minimum value of negative 25. So I want to make sure I can capture negative 25. So I've set my y min to be a negative 30. So next, if we hit graph, there is our function on the closed interval 0 to 6. And there we see it looks like we do have an absolute minimum there at 5. There's a couple ways we can check this. If I hit second calc and hit enter for option 1, if I enter 5 for our x value, there is our absolute minimum there at 5, negative 25. Another way that we can do this is to hit second calc and then go down to minimum and calculate that minimum. Hit enter. Now it's asking for the left bound. So I want to use my arrows to move my cursor to the left side of that minimum. Alright, I'm on the left side, so I'm going to hit enter. Now I'm going to use my arrows to move my cursor to the right side of that minimum value. And then hit enter. Hit enter one more time so that it guesses for us. And there is our minimum occurring at x equal 5, and that minimum value is a negative 25. Now on this closed interval, we said that we had an absolute max at 0, 0. And notice that does look like the absolute max there. If I hit second calc and hit enter for value, hit 0, enter, there's 0, 0. So that endpoint is our absolute max on that closed interval 0 to 6. In this example, we're asked to find the absolute extrema, if they exist, of the function x minus 4/3 x cubed over the interval 0 to infinity. So now we're working over an open interval 0 to infinity. Our first step is to find our critical values by taking the derivative. So the derivative of this function, f prime of x, is going to look like 1 minus, bringing the 3 out in front, we're going to have a 4x squared as our first derivative. Now setting this derivative equal to 0 to find our critical values, we're setting f prime of x equal to 0, so that's going to look like a 1 minus 4x squared equal to 0. So adding 4x squared to both sides. Dividing both sides by 4, we have a 1/4 equal to x squared. Taking the square root of both sides, we get that x is equal to the square root of 1/4, positive or negative, square root of 1/4 I should say. So now we get that x is equal to a positive 1/2 and x is equal to a negative 1/2 as our critical values. However, keep in mind we're looking at the interval 0 to infinity. Therefore, we can ignore x equal to negative 1/2 as one of our critical values because it is not in the interval 0 to infinity. So, we only have one critical value on the interval that we're looking at. Since we're working on an open interval, it's not closed, and we have one critical value, then we will use the maximum minimum principle 2. So we will use the second derivative to determine whether this critical value is an absolute maximum or an absolute minimum. So let's find the second derivative. F double prime here, taking the derivative of the first, is going to look like a negative 8x. If we plug 1/2 into the second derivative, f of a 1/2, we're going to get a negative 4. Since negative 4 is less than 0, our second derivative is negative, which tells us we have an absolute maximum. To determine what that absolute maximum value is, we're going to plug 1/2 into our original function. So f of 1/2. So we have 1/2 minus 4/3 times a 1/2 cubed. When we simplify, that comes out to be a 1/3. So our absolute maximum value is 1/3, and that is occurring at x equal 1/2. Since we are working on an interval that is not closed, and there was only one critical value that turned out to be an absolute maximum, that means we have no absolute minimum. We can check our work in our graphing calculator by hitting y equals and then typing our function into our y1. So we're typing in x minus 4/3 x cubed. Next, when I hit graph, here's the graph of our function, and right now I have my viewing window set from 0 to 3. Now we're looking at over the interval 0 to infinity. But since our absolute maximum was really small and it occurred at x equal 1/2, I've zoomed in along the x-axis. So I've set the window to be 0 to 3 along the x-axis. And then for our y min and y max, I've got that set at negative 5 to 5. So going back to our graph, there is our function. Now to double check that absolute maximum, I can do it a couple ways. Hit second calc, hit enter for value, and then type in 1/2 or 0.5. Enter. And there we see that absolute max there at 1/2, and that absolute maximum value looks like 1/3. Now, notice how we had no absolute minimum value, and that's because our function keeps going and going to negative infinity as our x values get larger and larger. So as our x values get larger and larger, this function it just continues to decrease and go to negative infinity. Therefore, we have no absolute minimum.